I'm the manager of metering and sustainable electricity with Saskatoon Light Power. So I'm going to talk to you about a few different initiatives that we're working on, and Braden wanted to really focus on the landfill gas project and a solar project that we're doing out at the landfill, and then talk about another possible application that we're looking at to use some waste heat from the landfill gas engines. So as far as my background, I graduated from electrical engineering here in 1991, and I spent 15 years working for gas pipelines. So I spent 5 years with a large gas pipeline in Alberta, that is now part of TransCanada Pipelines. And then I spent 10 years in Regina with Sask Energy, or TransGas, which is the high pressure transmission pipeline owned by Sask Energy. And then about 10 years ago, moved back to Saskatoon, did some consulting on for Sask Power at their coal plants down in the south part of the province, and then started working with Saskatoon Light Power 9.5 years ago. So I don't know how much you know about Saskatoon Light Power, but we're an electric utility, distribution utility owned by the city. And we provide electrical service inside the 1958 city boundary. And so what happened, well, we've been around since 1906, since Saskatoon became a city. And we used to have our own generation plants in the city, and we did everything: generation, transmission, distribution. In the 50s, the province went and bought up most of the electric utilities around the province, except for Saskatoon's and Swift Current's. And so that's why we're limited to our 1958 city boundary. So when that deal was reached, or when it was decided to keep our utility, we couldn't grow outside of that 1958 city boundary. So that's the pink shaded region there, with the exception of the university. So the university takes power directly from Sask Power at 72,000 volts or 72 kV and distributes within the campus here. So this is our very first powerhouse. It was built back in 1906. Believe it or not, it still stands today. So if you've ever done a tour at the water treatment plant, it's integrated into the water treatment plant. You can still see that same structure. This was a coal-fired plant with just 2 units way back when. And later, the city built the larger Saskatoon powerhouse, which eventually was sold to Sask Power and became the AL Coal Power Station, which is now down at River Landing. So it was torn down, I think, in the late 80s or early 90s. And now that's part of River Landing. So I'll talk to you about some of the different environmental initiatives that the city is working on. And back in 2009, the city council adopted the Energy and Greenhouse Gas Management Plan for the city. And that's a fairly detailed plan. I think it outlined 70 different initiatives for improving energy efficiency and reducing greenhouse gas emissions in the city. And that was both for the corporation of the city of Saskatoon and for the community at large. And that's a public document you could download from the website. And then in 2010, there was a large initiative to do some consultation with the community, and this was called Saskatoon Speaks, and that's this document here. There were over 7,000 citizens involved in a discussion around what they wanted Saskatoon to look like in the next 50 to 70 years. And in that time frame, Saskatoon is expected to grow to over 500,000 people. So very high growth rate expected for the city. But a lot of what the focus was on was becoming more environmentally friendly. And then from that community vision, City Council developed the strategic plan. And the strategic plan looks at a 10-year window. So it outlines a number of strategies for or goals for the next 10 years. And again, a lot of those are environmental initiatives. So one of the things that we do at Saskatoon Light Power is we allow our customers to generate some of their own electricity. This is a house in City Park. and they have solar panels on the roof of their house and on their garage. And this house, I think, is net zero for electricity. So over the year, they produce enough power from the solar panels to meet their entire electrical needs. But that doesn't mean that they don't use some power from us. So the net metering program allows customers to operate in parallel with our distribution network. And when they're producing more energy than they can use, they sell it back to us, so it comes out onto the grid. And when they need electricity, when they're not producing enough or at nighttime, then they buy from us. But they receive credit at the same rate that they purchase electricity at. So it's net metering, and this house, for example, I think has about six kilowatts installed. And that's usually enough for a net zero over a year. We have 45 customers interconnected.
Sorry, I've always been curious about that when houses use solar panels on the roof. Like, how hard is it to tie into the grid with that? Like, is that quite like it takes like a week or a month, or is it pretty easy at this point?
It's not, like, technically it's not difficult at all.
Yeah.
All of our electrical meters are bidirectional, so they're already set up for net metering. The process is what takes the time. So there's an application process and review process to go through. So if you were a Sask Power customer, that might take 6 months or a year to get. We've got a very streamlined process at Light Power, and you could probably do it within a month if you were ready. So we're usually not to hold up on any solar project. Yeah.
Do you have like a limitation then on the number of net metering houses? Like you say, like if we have, you said like everybody in the city decides to do it, then
right.
You're gonna have, and they say produce enough that everybody else, so you can store it somehow. Then
yeah.
During evenings, everyone else can just use that generated power. That you're like, hey, well, we need to make some money, so
right.
we'll
yeah.
limit to like say a quarter of the people or something.
Yeah, we haven't limited it at all at this point. And we have only just a small fraction of 1% of our power actually comes from net metered customers. So we have 45 right now. If that were to grow to like 50%, that's when it becomes a concern. So probably at about 25%, we'd start looking at what we need to do. But if it becomes 50%, like in some places in Australia, for example, they do have 50% distributed generation like this. And then what happens is voltage stability on the network becomes a concern. So when clouds come over, the production from the solar panels drops off very quickly. So your system has to respond to that. But that usually isn't a concern until you're at that, close to 50% penetration. We're way off that. But it could happen. Solar costs are coming down every year, and that that could happen in the future.
Sorry, I think you said, but I missed it. How much percent, or how much is already being
I think right now we're at about 1/50th of 1% of our annual electrical sales. So we sell, over the year, we sell about 1,100 gigawatt hours of electricity. I think we're at about 35 megawatt hours that come back onto the grid. So very, very small percentage. We buy, I didn't explain this, but we buy all of our electricity from Sask Power at 138,000 volts. And then we have about 22 substations around the city. And so we'll transform it down to distribution levels and then resell it.
Yeah, I think you kind of mentioned this, but I might have missed it. I know with Sask Power, if you tie into their grid, you don't. You just get credit, right? Towards if you overproduce, right? If you put more into the system, they give you credit, but they don't pay you like a check at the end of a month, right? Are you guys different?
They have 3 different programs.
Okay.
So the net metering program is just credits.
Okay.
So they start, I think it's March to March. So if you don't use all of your credits by the end of March, then you would lose them. But everybody does, because that year is set so that you can, at the end of the winter months is when it ends. So you'll use all your credits through the winter months.
Okay.
But they also have what's called the Small Power Producers Program, and that pays a lesser rate, but it's a cash payout.
Cash.
And we offer the city offers net metering and small power producers.
Okay.
And then they also have what's called the Green Options Partners Program. That's for larger facilities like our landfill gas. And it uses that same rate. It's about 10 cents a kilowatt hour. And the residential rate's about 13. Another project we're working on is the smart meters, or it's called the advanced metering infrastructure. And so we're doing this for electricity and water meters. So the way this works is we've already installed about 60% of our customers have received a new smart meter. And that has a radio inside the meter, a wireless radio that uses a 900 megahertz license frequency. And we have, out in the neighborhoods, we've got about 65 data collectors. And they're collecting data from all of the meters about once every 4 hours, and then transmitting that back to City Hall. So there's a local area network out in each neighborhood that brings the data back from the electricity meters. The water meters actually use the electricity meters to get onto the network. So they'll use our electricity meters to get back to City Hall. And they're read again once every 4 hours. And then we actually use SaskTel's 4G network. So in each collector we have a wireless modem, and that brings the data back to City Hall. So at City Hall we have the head-end server that collects all that data, and we have what's called a meter data management system. And that stores and processes all the metering data that's coming in. And then very soon, well, this summer, we'll start billing off of that smart meter data. And so this is an exciting project for us. We also have, this is a program that we've started for our customers, and we'll lend customers an in-home display for a month or so that they can use in their home. And the in-home display uses that 900 megahertz network to communicate directly to their own meter. It'll only collect data from their meter. And then what they get is they get the hourly consumption over the past 24-hour period and the daily consumption over the last 30 days. And so you can use this to really see how much electricity you're using and when, and then make some behavioral changes, hopefully to reduce your consumption.
So for you guys, aside from just billing purposes, is there any advantages in being able to see what each household's usage, kind of how that fluctuates? What's the advantage for you guys to be able to see that?
Yeah, so what we can do on the electricity side is we can do an outage management system is one thing. So when these meters, when power is cut off to the meter, they have what's called a last gasp. So they'll say, hey, I'm out of power. It's just a capacitor in the meter that's charged, and they'll give you one alarm when the power goes out. So we can use that as part of an outage management system to restore power quicker. But an even more interesting application is we can do what's called virtual metering. And so we can aggregate all of the meters that are connected to an overhead transformer or an underground transformer, for example, and find out if power theft is occurring, what kind of losses that we have in our distribution system, and that, or if transformers overloaded, for example, if there's a bunch of electric vehicles charging off of one transformer, we'll know very quickly if that's overloaded. So we can do things like that. We can do what's called a volt. Is there any electricals in here?
No. I'd like to be.
So there's a volt bar control that you can do. So we can control our voltage to reduce the losses through that if we know the voltage at the end of each feeder. So we can do things like that. On the water side, they can also aggregate meters, and it's really interesting on water. About 17% of the water that's pumped from the water treatment plant is unaccounted for. So a lot of it's leaking underground. They don't know where. So you can do distribution meters along the pipeline and find out where those losses are occurring. So we'll know of water main breaks before they're actually on the surface, that kind of thing. So there's a lot of, I'd say, distribution optimization applications that we can do with that kind of data. So that's really where the electric utility industry is going, is big data or data mining or those kinds of applications.
I know that in BC there was quite a backlash to the whole smart meter
Right,
program.
yeah.
Was there? Did you guys see kind of the same thing in Saskatoon as well?
Not so
or
much. So in BC and in Ontario, the governments there mandated that you had to implement a smart meter program by a certain date, and the utilities didn't give customers a choice. So they said you're getting a meter. And so what customers are usually, or what the public's usually concerned about is, one thing is radio frequency emissions. Some people claim they're EMF sensitive, which is not a scientific diagnosis in any way. But so a lot of people are concerned about that. And the other is protection of privacy. And so none of them are real. The EMF from a smart meter is much less than a smartphone. And it's usually much, much farther away from the human body than a smartphone. But we've allowed customers a choice, so we've allowed them to refuse a meter. And so now utilities are offering opt-out programs where you don't have to take a smart meter, but you'll have to take an electronic meter of some kind, but it won't have a radio in it. And when they opt out, they actually pay a fee every month to have their meter read manually. So we'll offer some program like that. So we've had like 1 in 500 customers refuse. So we've got about 70 refusals so far.
Yeah.
And that's what the
great. Yeah.
We also do school tours at our office down in Stonebridge. And so we do about 30 school tours every year. This is usually for grade 6 and grade 9 students. So in grade 6 and grade 9, the science curriculum includes electricity. And so we see a lot of those students come through every year. So about 830 students a year. And we talk about renewable energy, and we talk with a lineman, electrician. We tour them through our meter shop. And in the pictures here is we've got a smart metering display in our meter shop that talks about how the in-home displays work and that kind of thing. And so it's really just focused around science curriculum to give them some hand-on exposure to electricity. We've also looked at wind in the past. So in 2010, we did a wind assessment out at the landfill. And so it's really difficult to site a wind turbine of this size. This was a 2 megawatt wind turbine within a city. And so the concern with wind is noise and shadow flicker. So you have setback distances from homes. And the guideline in Canada is a minimum of 550 meters from the nearest residence is the setback distance for a wind turbine. The only location in the city where we could really accomplish that was out at the landfill. And it also happens to be the best wind resource in Saskatoon. And so this was actually going to go on top of the landfill. And by doing that, you get about 35 meters additional height. And the higher you go, the better the wind resource is. It's more laminar flow, less turbulence, and better conduction. And so we did do, for a year, we had a meteorological tower installed out at the landfill to monitor the wind. And we would have produced, if this project went ahead, we would have produced about 28% capacity factor. And what capacity factor is the average power production of a wind turbine in this case, as compared to its nameplate capacity. So 2 megawatt wind turbine, a 28 or 30% capacity factor means you're on average producing about 600 kilowatts. So that's not bad. That's would have been financially viable, but we actually did a request for proposals for this project, and they just came in a little too high on the bids. Most of the reason for that is to bring a crane in to install. This was an 80-meter hub height on the turbine, and so you have to construct and demobilize that crane, and that's what most of the cost is for the project. So if you were doing a wind farm, it would have worked. but for a single wind turbine, it just wasn't financially viable. So we canceled that project. We're also looking at doing hydropower at the weir. So in 2010, we took a report to City Council, and we studied it for a year ahead of that, so we had a consultant do a pre-feasibility engineering study and the environmental baseline study for this project. And so this is a rendering of what that project could look like. So this is the existing weir you can see here. And this is the university side of the river, or the east side of the river. This is our hydro facility. And then what you see here is there was a Whitewater park that was proposed to be constructed as well as part of this project. And then we also proposed to build a pedestrian bridge across the weir at that site. So right now, you've probably seen people walking across the train bridge, CP rail bridge. The CP rail washed their hands of that 100 years ago. And so any liability that, if someone was injured crossing that bridge, it's on the city. So CP wants people off, the city wants people off, and this would be a perfect place to do a pedestrian crossing. And so that's also part of the project. So we are taking a report next month to City Council. And over the past 5 years, we've met with about a dozen hydro developers and other financial partners that are interested in this project. And so we're taking a partnership proposal to City Council for consideration. And if this project were built, we're estimating that we would start operation in 2020. So usually hydro projects are 10, 15 years in development. So we'd be within that, kind of within that range. And so the concept here is, well, two things you need to produce electricity. Yeah, question?
So for that time for 2020, in the meantime, is there a lot of planning that goes into it? Is that all the legal stuff?
Yeah, the full feasibility study would have to be done, which includes about 60% of the design. We'd have to do a full environmental assessment, permitting, and then the construction is actually over 2 seasons, because you have to coffer dam half the river to build the hydro 1 year, and then the other part of the project is we're raising the water level. So you coffer down the other half of the weir and raise the water level. So it's a 2-year construction project. So that's why the lengthy time. Yeah. So the concept here is we would actually raise well, there's 2 things you need for hydro power. You need a lot of water flowing through. So all the water that comes through Saskatoon has previously gone over Gardner Dam at Cotter Creek Generating Station. And there they generate 180 megawatts of electricity. And then you need it to fall over a vertical distance. And, the existing weir is about 3 meters in height. And we have about 2 meters in head average throughout the year falling over the weir. And so we're considering raising the weir by 1 to 1.4 meters to get more head and more power. We do that by adding an inflatable rubber dam on top of the weir. Basically, it's a big conveyor belt, folded and clamped, and then inflated with low pressure air. And, that's how you raise the water. And so this is the hydro facility, and there's 3 turbines submerged about 10 meters below water level, and then the tail race coming back out to the river. So very low impact. There's no reservoir. It's a run-of-river project, and this would generate enough power for about 3,500 homes. Payback is probably 15 years, and the hydro facility has 60 to 80 year life. So we're excited about the project and financial benefit there as well for the city. So the Whitewater Park, there was a community group that approached the province about getting funding. So the province gave them $100,000 to study the feasibility of this project, and they hired a mechanical engineer, designer from Colorado, who was a 6-time U.S. Olympian kayaker, and he designed the Whitewater Park that was used in the London 2012 games. And it's very similar to the facility proposed for Saskatoon. So to create whitewater, you need the same thing. You need a lot of water and a lot of head. So there's that's what that part of the project is. So this is a whitewater channel, and you can dial that up or down for different users. So there's a head gate at the inlet to the channel, and you can control the amount of water flowing through, and then you can change the configuration of the park. So you cut the water off, cut the water flow off, an operator would jump in. It's kind of like Lego blocks. You reconfigure the park for a different user, and then open up the head gate. And then the other component is what's called a standing wave. So you could, if this were built, you could surf in Saskatoon. And so surfers, you can surf in a kayak. You point it upstream, or actually on a surfboard. And if this were built, this would be one of the largest standing wave parks in the world. So the mayor's really excited about it. The city doesn't want to spend any money on it, but it would be a tourism initiative, so that's why the province was involved.
Is the other part of the river flowing, sorry, like
Yeah. So what we do is during the day we would just have just for UV protection of the rubber dam and the weir, we'd have just an inch or two of water flowing over.
Okay.
At nighttime we inflate it all the way and force all the water through the hydro station.
How about the like aquatic life and stuff? Is that?
And the hydro. Oh, yeah. What I don't. We built a fish bypass channel on the west bank.
Oh, okay.
So right now there's a fish ladder on this side that only works like a week or two a year. Otherwise it's ineffective. This would be a fish bypass channel that can be used year round.
Yeah.
And it's about 100 meters long. It has, I'd say 1 to 2 cubic meters a second flowing through it. And then pools up all along, so fish could easily migrate up and down the bypass channel. And there'd be some fish habitat in that area as well.
Is this project a for sure thing in the next 5 to 10 years?
Nothing's for sure. We're still trying to get it approved by City Council. We have hopefully within the next month or so we'll have a really exciting announcement to make. So what partnerships. So this is what I came to talk about. Before I show you some pictures, I just want to play a bit of a cartoon here. So this is an animation of what the Landfill Gas project is all about. And this was built, we started construction in 2012, and we started operation in late 2013, and then we started generating power about 2 years ago using the landfill gas. So this is actually up and running. So landfills, about 40 to 50% of the garbage or the waste that goes to a landfill is organic, so food and yard waste. And as that organic material breaks down in an anaerobic environment, so anaerobic means absence of oxygen. So within the landfill mass, it's an anaerobic condition. And temperature is actually like 35 to 40 degrees Celsius year round in the waste mass. But as that waste decomposes, and it takes 50 to 100 years to totally decompose, depending on its content, it's emitting methane, CH4, and carbon dioxide, CO2. So it's about 50 to 55% methane, and 40% carbon dioxide, and then there's nitrogen and hydrogen sulfide and some other trace gases that come off. So the landfill in Saskatoon has been operating since 1955, and between 55 and 2014, all of that gas was escaping to the atmosphere. And methane is a very potent greenhouse gas. So in most parts of the world, it's legislated that you have to control or manage your landfill gases at a landfill once you reach a certain size. So we have about 5 million tons of garbage or waste in place at the landfill. And that's large enough that we should be regulated. It's not in Saskatchewan yet, but pretty much every province and state, it's regulated that you have to collect your landfill gases. So what we did is we capped the landfill with clay. So we added about 1.5 feet or 450 millimeters of clay and compacted that down. And what that does is traps those gases in the waste mass. And then we drilled wells. So we drilled 28 wells into the waste, about every 60 meters. So each well will draw gases from about a 30-meter radius around. And it's, all it is a plastic pipe, like an high-density polyethylene pipe, 4 inches in diameter. It's perforated throughout the pipe. And the deepest well is 33 meters deep. So it comes to within about 1 meter of the bottom of the waste. And then what we do is, using a large vacuum compressor, shown here, we induce a vacuum on the collection system. All those wells are connected with underground piping back to the collection facility, and draw those gases off the landfill. And usually we're sending them to the power generation facility like this. This is an animation we showed at grade 6s, so it's simplicity. And then we also have an enclosed flare. So when our engines are down for maintenance or we have an outage for some reason, we'll flare our gas instead of burning it in the engines.
Do you have to dry the gas? Like, does liquid or water vapor get into the system?
Yeah, it does. And I'll show you the pictures of what we do to process the gas. So the reason we flare the gas, some landfills just collect their gas and flare it off. They don't use it for anything. And that they have to do that at minimum. So what you're doing there is you're destructing the methane. And methane is about 25 times more potent as a greenhouse gas than carbon dioxide. So when you burn methane, the byproduct is carbon dioxide. But you're actually reducing your greenhouse gas emissions significantly by flaring that gas. And so if we're not burning it in the engines, we're burning it in the flare. But usually we generate electricity with that gas. So we've got 2 large reciprocating engines that use that gas, and they drive. So I'll show you some actual pictures now of the. So we started planning for this project in 2008. And I should mention, we're not a leader in landfill gas management. We're one of the last major cities in Canada to do this. So, but we've got a really good facility. So most states and most provinces already collect their landfill gases, but we didn't start this project until 2008. And as I mentioned, construction started in 2012, and we started operations of our power generation facility in March of 2014. So the cost of the project was $15 million. About half of that was funded by the federal government and the provincial government, and then the city funded the other half of the project. So by collecting those gases and generating electricity, we actually sell the electricity back to SaskPower through one of those programs I mentioned called the Green Options Partners Program. And we generate about $100,000 a month in revenue from that. So about $1.3 million per year. And that's enough for about 1,300 homes. Enough electricity for 1,300 homes. So 13 gigawatt hours each year. And then we reduce greenhouse gas emissions from the landfill by over 50,000 tons per year. So that's huge. That's like removing over 10,000 vehicles from our roads. And the picture here is the clay cap that we put on the landfill. So 18 inches of clay soil, and then compacted down to trap those gases. This is a power generation facility. So if you drive out on Valley Road, off Circle Drive South, if you look, if you're heading out on Valley Road, if you look to your right, you'll see the landfill gas facility there. And so that's this picture here. So we have two engine generator sets in that building. And those are the exhaust stacks that you see there. That's our first powerhouse. This is the powerhouse that was at River Landing and was eventually sold to SaskPower, and it was a 10 megawatt coal-fired power plant. So this is the third power plant the city's ever built. And just an overview of the project. So here's the river. This is Circle Drive South, the train bridge, Queen Elizabeth Power Station. There's the landfill. And so our well field, we've just capped the older part of the landfill. It's about 12 hectares of land. And the landfill is still active. So we closed part of it and capped it, but there's still garbage going to that landfill. It's expected that we'll still get another 30, 40 years out of that landfill. And so we're continuing to expand the landfill. And eventually we'll expand the well field into those new cells as well. So we have 28 wells on the landfill, and then we have a collection header that eventually will go around the entire landfill. And this goes back to a gas collection facility on the east side of the landfill. The reason it's there is because of condensate management. Someone mentioned, yeah. And so water, of course, flows downhill. And so we collect all the condensate here in the glass, and that's why the gas collection facility is on this side of the landfill, down towards the river. And then we pipe that gas, once it's processed, out to the power generation facility here. Another project we were working on that was just canceled last month, and another reason that we built the power generation facility out here is we were going to do a project with Sask Energy, and they have, out of that site, they've got a very large regulating station where they bring natural gas into the city, and they cut the pressure from about 800 PSI down to 100 PSI so they can distribute it in the city. We were going to do something that's called a turbo expander that would use that pressure drop to drive a generator and produce electricity. And when you do that, you have to preheat the gas because it'll freeze otherwise. So we're going to use waste heat from the engines to preheat the gas before that. But Sask Energy wanted out of it, I think because of gas prices or whatever. So that project was canceled. That's another reason we built it over there. We could have built it over here. But it turns out, which I'll talk about later, is good. It actually should work out for us there. This is an aerial view of the landfill. So there's the river. Queen Elizabeth Power Station's over here. This is the capped area of the landfill where our well field is. And our gas collection facility is here. And that's the flare. It's a 40-foot flare. So if you drive by the site, you'll see that there. And then we pipe that gas back out and we go under Valley Road. And this is our power generation facility here. That's Sask Energy's facility. And right across the road from us, if you've been out there, Saskatoon Transit's building their new transit facility out there. And this area is where the city yards will be moving very soon. So in the north part of downtown, right now we have our city yards. I don't know if you've ever seen them, but kind of by the south of the flour mill there is where the city yards are. But that whole area is proposed to be redeveloped for commercial residential. And so all those facilities will be moving out here. And what we propose to do instead with that heat is have a mini district energy system that will heat those buildings in that area. So instead of using it with that Sask Energy project, one of the options is we can do a district energy facility there. So yeah, there's the clay soil beam. So there's 2,000 truckloads of soil added to the landfill. Initially we were trucking it from a site out by Martinsville into the city, And then had an idea, Circle Drive South Bridge was just being built at that same time. And they were removing the cofferdam from the construction of the bridge. And we tested that soil, and it's a clay-like soil as well. We tested that and found out we could use that as the cap. So we just moved that onto the landfill. So it saved the pile. And, both for that project and for ours. And then we hydro-seeded it, and so we would establish vegetation. It's very important for soil erosion, to prevent soil erosion. So that's the hydro-seeding that was applied back in 2011. 2012, sorry. This is the drill rig that drilled all the gas wells. And so there you can see it set up. And that's the, so these gas wells, I think they go from, the shallowest is 15 meters and the deepest is 33 meters. So that's a drill rig like you would drill a water well or whatever. So 100 feet deep is the deepest one. And then they put the perforated pipe down and cap those wells.
How do you make sure there's no leakage like around that?
There's a bentonite that's applied on the wellhead,
Okay.
and then it's just compacted around. So it's all enclosed. Like the perforated pipe starts about 2 meters deep. So it's bentonite that keeps the gas in the well. This is the underground piping. So this is the gas collection header and pipeline that's going out to the power generation facility. There's actually 4 pipelines here in this picture. So this one is the gas collection header, so it's under vacuum. What these are, one's a compressed air line and the other is a condensate pipe. So all throughout the well field we have condensate drain traps. So when that gas comes off the landfill, it's very hot, so it's 35 to 40 degrees Celsius, and it's 100% saturated with moisture. And so when you draw that gas off, it immediately cools and will release some of that moisture. And so those condensate traps will fill up. And so we have pneumatic pumps throughout the well field, and so compressed air operates the pneumatic pump and then pumps the condensate back to the collection facility. And then this one's the pressurized pipe that's taking the landfill gas, clean, dry landfill gas out to our power generation facility. So just some more pictures of that piping going in. This is our gas collection facility, so the vacuum compressor and the processing is inside that building, and this is our flare. So that's an enclosed flare. So there's 2 types of flares. There's an open flare where you can see the flame, and there's an enclosed flare like this where you can't. And these are 98% efficient in combustion. So even when this is operating, you can't see anything.
Is that just for the public, like, so they don't see the flame all the time?
No,
Or is
it's
that-
for combustion efficiency.
Oh, okay.
Yeah. So the city of Regina has a gas collection facility as well, but they have an open flare, so you can see it when it's burning. And if there ever is a carbon tax or carbon credits offered in the province, like in Alberta, you have to have an enclosed flare if you burn your gas in order to claim credits. This is where the landfill gas comes in from the well field under vacuum, and it goes into another condensate trap inside the building. So water's dropping out of the gas all the way through the process here. So that's our first liquid knockout there. And then this is the vacuum compressor. That's a 200 horsepower electric motor driving the compressor. And so that's what draws the vacuum, and then the discharge pressure is about 10 psi. And it's about 16 inches water column in the back. This is a cooler dehydrator. And so after the gas comes out of that compressor, whenever you compress gas, it heats it up. And so we have to cool that gas. And we also have to cool the gas to knock the moisture out of it. So we cool it, and then this chiller, which is the blue light in here, cools it down to a dew point of about 4 degrees Celsius. And that should knock out the rest of the moisture. And then we have what's called a coalescing filter to remove any particulate matter that's still in the gas at that point. So when it comes out of this, it's clean, dry landfill gas. We don't remove any H2S or CO2 or nitrogen from the gas. Obviously they're CO2 or nitrogen or inert gases, but you can still burn the methane even with them in the mix. And then this is our power generation facility. So we have 2 Caterpillar engines, and these are 1,200 horsepower, 16-cylinder reciprocating engines, just like in your car, but much larger, stationary engines. And on the other side is a generator. So the generators are 815 kilowatts each. So combined, we generate 1.63 megawatts, and they're operating 24/7 throughout the year. Now, just like in your car, only about half of the power, actually less than half of the power that's generated from an engine is shaft horsepower. So the drive that turns the axles in your car, or in this case, that spins the generator. And well over half of it is waste heat. So it's that's the reason you have a radiator in your car, just to get rid of the heat. So we have radiators on the other side of the building here, shown there, to get rid of that heat. And so half the heat goes out through the jacket water, cooling water for the engine, and also through the exhaust. So what we have here, they're not installed yet, but we have heat exchangers on the jacket water. And these are just spool pieces that are put in place right now until we have a use for that waste heat. And so when we do, we'll install those heat exchangers here, and that, if we do a district energy facility, that would heat glycol, and the glycol would go out to heat the other buildings in the area. And then what's shown here is an exhaust gas heat recovery boiler. So it's a 2-pass boiler. Right now they're being bypassed, but the exhaust gas will eventually, when we turn the valve, will come down through the boiler and back up and heat glycol to capture that heat from the exhaust gas. And we have to synchronize to SaskPower's grid. So these are the protection relays and synchronizers that do that. And then this is our interconnection to SaskPower at that facility. So we generate power at 600 volts, and we transform it up to 25 kV, and then supply it to SaskPower. So we're also doing a solar photovoltaic demonstration project at the site. So you can't really see it here, but on this is the Valley Road interchange here. But about half of the site here is we've allowed for future expansion. So in 30 or 40 years, when that landfill doubles in size, we'll add 2 more engine generators to the site. So we have the site leveled already for that, but the other half of the site's not being used. So what we're planning to do is install solar panels, which usually last 20 to 25 years, on the other half of the site, and do a demonstration project there, which would be a net metering application to SaskPower. And so what we're doing there is this will be the largest solar power cooperative and first in the province. And so anyone can buy a solar panel and get the revenue off of that. And so we partnered with the Saskatchewan Environmental Society, so they're going to own half the project and the city's going to own the other half. And we're trying 3 different types of PV systems. So there's a fixed angle solar panels, and then there's seasonally adjustable panels, which are shown here. And there's also a tracking system that will track the position of the sun throughout the day. And this is a picture of our largest, the largest customer that we have interconnected, which is the university. So at their horticulture facility on 14th Street, they have 20 kilowatts of solar panels out at that site. And what they do is 4 times a year, they adjust the angle on the panels to match the position of the sun. So this time of year, there'll be maximum vertical angle, usually about 60 degrees, to capture the most sun in the winter, and then they'll be lowered down in summer when the sun is higher in the sky. And so you're trying to, solar panels generate the most power when they're perpendicular to the sun. That's what we're trying to accomplish. And then we're also installed, so there's a fixed, then there's the seasonally adjustable, and then this is a solar tracking system on the left. And so what they do is they have a light meter that will measure the intensity of the sun and solar radiation, and they'll adjust the angle throughout the day to try to stay perpendicular to the sun.
That one's in Swift Current, right?
That's in Swift Current, yeah.
Yeah.
Yeah. And this one's actually a system designed by Lockheed Martin, which is a defense contractor. And so the reason they do renewable energy is, and solar in particular, is ships use a lot of solar power. They're basically floating cities is what they are. So they have to generate all their electricity on the ship. And the motor for this is a turret motor for like a gun. This was installed at a hotel in Swift Current. And ours won't be the Lockheed Martin system. We actually, Saskatchewan Polytechnic heard about our project and they donated a tracking system to us to install on the site, so that will be going up this summer. And then this is a fixed ground mount system that we'll be installing as well.
Something I've never understood about the tracking ones is where did they get their power from? Is it just from themselves, or do they get it fed through something else too?
Usually it's themselves, like they're self, but pretty much every solar system is net meter interconnected to a grid, and so you'll draw power off the utility. But if you don't, you'd have a battery system.
Does that Lockheed Martin one require less energy or like less moving parts for that tilt?
Yeah, there's only it's just a little servo motor.
Okay. Because I've heard that's one of the things that kind of is the downfall of the tilting one is
Yeah.
moving parts and wearing out.
Yeah, it's a really simple design. It's just a little servo motor. It doesn't operate very often. It just moves like a degree at a time. So it's very low power, and very robust because it's built for defense. So it's in this case. Yeah. But yeah, that would be the concern for maintenance.
And is that one in Swift Current single axis or dual axis?
It's a single axis.
Okay. And what about the one that you guys?
We have both. So the SciAst or Polytechnic donated 2. So one's a single axis, so it only moves in about one axis, and the other one's dual, so it'll adjust this way and this way to match the angle this time. And so we'll be metering each system individually using our new smart meters. And the smart meters, even though they're only read once every 4 hours, they record 15-minute production data. So we'll know very accurately what the production is throughout the day. through that. And we'll put this on our website as well, so public can have access to it. So the last project I wanted to talk about, we're already over time here, sorry, but this is another project that we could build to use the waste heat from the landfill gas engines. And this is called organic Rankine cycle heat recovery generation. So there's some mechs in the room. So have you heard of, you must have heard of Rankine cycle?
Oh, yeah.
And the organic just means it's using an organic compound, which in this case is pentane. Okay. C5H12 is the working fluid. So this is a power plant cycle for, this could be a coal plant, it could be a geothermal plant, it could be a heat recovery system like we're talking about here. So let's just say it's a coal-fired plant. So you're burning coal to produce heat, and you're increasing the pressure and temperature of a working fluid. So in a coal plant, it's water to produce steam. So in the boiler, and that steam will go through a turbine, which will be coupled to a generator to produce electricity. So there's heat in, there's work out, and then in this case, once the steam comes out of the turbine, it has to go through a condenser to be converted back into water. And so there's heat out through the condenser, and then there's work in the pump to just keep this continuous process. That's power plant cycle for any type of thermal power generation. So very simple. And this is the temperature entropy curve, or the Rankine cycle curve for thermal power plant. So the lowest amount of energy in the cycle is here. You add energy by pumping the fluid through the system. And then you add heat in the boiler or the heat exchanger. And so this, at this point, point 3 is the most energy that's in the working fluid. And then it'll reduce in temperature and pressure through the turbine. And so that's where your work is coming out through a generator. And then the condenser, you're removing heat from the fluid to get back to a liquid state. Does that make sense? So that's the Rankine cycle curve. So there are 5 projects in the province right now that I know of that use this technology. 4 of them are on Alliance Pipeline's compressor stations in Carrabert, Lorburn, Alameda, and one other one. But they're all in Saskatchewan, so about every 100 miles along the pipeline. They have so Alliance Pipeline operates a natural gas pipeline taking Alberta gas down to Chicago at very high pressure. So what they have on the Alliance Pipeline is they have gas-fired turbines that drive compressors, and the compressors push the gas down the pipeline to Chicago. And gas turbines are very inefficient energy users, so about only 1/3 of the energy that's put into the turbine comes out as shaft horsepower. 2/3 of it is waste heat. So Alliance Pipeline wanted to use that waste heat for something. And so they do Rankine cycle heat recovery. And so on the gas turbine exhaust, it's just like our system. It's a well, in this case, single pass boiler. And they heat up pentane, which is the working fluid here in the system. So the pentane comes into the heat recovery boiler and is eventually flashed into a vapor. And so the exhaust comes off the gas turbine and through the heat recovery boiler and then out to atmosphere here. When that pentane flashes off, it's very high pressure, high temperature. And then it goes through an expansion turbine. So any turbine, to make them work, you have a high pressure, high temperature gas coming into the turbine, and across the turbine it loses a lot of pressure and a lot of temperature, and does work on the shaft, which is coupled to a generator. So that's any turbine: steam turbine, gas turbine, expansion turbine. They all work the same. So that's an expansion turbine. The pentane comes out. It's still a gas at very much lower temperature and pressure, and then it goes through a condenser. And this is just an aerial fan radiator to cool that gas and back into a fluid, and then pump back so it's a continuous process. Does that make sense? So the rest of this is just pictures of their facility. So this is the compressor building on their gas pipeline system. So the high pressure gas comes out here and down to Chicago. This is the gas turbine exhaust, and the heat recovery boiler is here. And so if they were to bypass the boiler, it'll go straight out to atmosphere, out the stack, or it'll be forced down through the boiler when the system is operating and out through the stack here. This is the condenser, and then I'll show you some close-up pictures of the unit here. So that's the exhaust recovery boiler again. So heat exchanger and exhaust. So off the heat exchanger is the glycol piping that goes out to the heat recovery unit. And that's what's shown here. So this is the glycol piping coming off the boiler and out to the unit here. This is the evaporator and the condenser there. And incidentally, this is the gas turbine is about a 25,000 horsepower turbine that drives the gas compressor for the gas pipeline. And they're recovering 5 megawatts of electricity off the system.
So what pentane?
Pardon?
Why pentane?
I don't know. I'm not sure. I guess it's an easy fluid to work with. It's combustible.
It's more volatile, so you don't need a high temperature.
Yeah. So closer up picture of the vaporizer there. And this is the expansion turbine. You can't really see it, but it's within this jacket here. So it's insulated to keep the heat in as much as possible. And it's coupled through a shaft here to the generator, which is on this side. So that's the entire expansion turbine right there. And that's 5 megawatt turbine. And then that's the, when the pentane comes off the turbine, goes through this header and through the condenser. So a bunch of aerial fans are spinning underneath it. And those are the pumps on the low pressure fluid side, so to finish off the process. So a little bit over 10 here. Any questions?
There's been some issues with the feasibility of the landfill project. Like for instance, I think the one in Lethbridge is shutting down.
Okay, I wasn't sure. I wasn't aware that Lethbridge had a landfill gas.
Yeah.
They have a biogas.
Oh, okay, maybe it's bio. Sorry, maybe it's biogas.
Okay.
But is your facility going to be totally sustainable, like management-wise, or are you going to require funding from the government to keep it operational?
The Lethbridge facility is quite a bit different.
Okay.
They take any kind of waste byproduct, like it could be cheese, manure, food waste, and it's trucked to the plant, and then it's added to digesters,
Yeah.
and they take off gas off the digester. So it's a much different process than we have. Ours is very simple compared to theirs. I was actually on a tour of their facility last spring. It's quite complex.
Okay, sorry, maybe I got them kind
Yeah.
of confused.
But landfill gas is there's over 500 facilities operating in North America. It's very proven technology. Requires a lot of maintenance. So there always is money going into it. So I mentioned we generate 1.3 million in revenue but about half of that is operating cost.
Okay, so that's what, I guess I was wondering.
Yeah. So right now, for example, one of our engines is down because we blew an exhaust manifold. So it's been down since February 5th. We're going to lose a month of production off that. So that kind of stuff's going to happen all the time. So they do take a lot of O&M to keep them operating. But we're legislated, well, we should be legislated. We eventually will be to control and manage our landfill gases. So we'll make sure that facility is always operating. On this side first, and then
Okay, just back to the smart meters. I know there have been, like you kind of said, like the EMF concerns aren't really real concerns, but I'm wondering if the software in them is hackable at all. Like, could you get in them either remotely or directly into it and kind of change it to what you want it to say, sort of thing?
So every meter manufacturer uses their own proprietary protocol, and that's not, I mean, that's locked down, so nobody can get that.
Okay.
A rogue employee could, I guess. But they also use, like the wireless system uses frequency hopping spread spectrum. And so a hacker might be able to get a couple frames of a message if they were able to get lucky and key in on the right frequency at the right time.
Right.
But it's jumping overall. No one knows that algorithm that's
Okay.
used for the frequency hopping routine. So it's very, you never catch an entire message.
Yeah.
And even if a rogue employee from Elster, which is our meter man, hacked in, we don't transmit any proprietary information. So all it has is the meter ID, which no one would be able to correlate to an address,
Okay.
and the actual meter data. So even if you were able to get some, and all you're getting is 15-minute production data anyway, so it doesn't tell you.
Okay.
But good question.
All that condensed water that comes from all the gas from the landfill?
Yeah.
Where does all that water go?
Wastewater treatment plant. So it's there's a lift station. So right beside our gas collection facility is a lift station. And same with all the leachate that comes off the landfill. It's pumped to the wastewater facility and processed there. Yeah. So it doesn't end up in the river. Yeah.
You were saying that they're looking at moving the city lot down near the landfill production facility. Are you guys contemplating putting photovoltaics on top of the building, or maybe even over the yard itself to increase production or offset costs, I guess?
They could do that. That would be a different branch of the city. Our jurisdiction, our franchise area
right.
ends right here.
Oh, no.
So this is Dundonald Avenue.
Yeah.
That goes south to the river. So this is Sask Power's area.
Gotcha. Oh, okay.
But the city, like the city yards, could decide to put solar panels on the roof. But we're actually the reason we're doing this the small scale. It's 40 kilowatts. We still call it small scale. Solar project is to evaluate what's the best type of system to install for a utility scale project. And we're looking at several sites around the city within our franchise area where we could do, and even outside. So for example, the city owns this quarter section here. We could do a solar project there while we're waiting for, maybe there's no development plan there for 20, 30 years. So in the meantime, we can do solar.
Yeah.
So we're looking at those opportunities.
Yep.
Once solar costs come down. So right now it's very marginal on economics, but within a couple of years it should be a money maker. So we want to spend a couple of years learning how solar works and what the economics are, and then make that big investment.
Cool.
And there's several sites. We can go on side of roadways, on other civic buildings, throughout in parks.
Yeah, because I've seen, especially airports down in, the southern U.S., what they do is they cover, chunks of the parkade to not only keep people's cars cool, but then also all that solar just helps offset the usage
Yeah,
of the airport. Because I mean, you're covering the area in tarmac anyway, and yeah, it may cost a bit to put up these covers, but you know, slap some solar panels on there and get something out of it at least.
exactly, yeah.
Yeah. Cool.
You said you were comparing like, fixed, single axis, dual axis. I thought there was a lot of research already done on that sort of
Yeah,
stuff. And
yeah, there is.
I think,
Yeah.
are you just doing it kind of as a demonstration for the public, just to see what works here? at
Yes
this
and no,
latitude,
yeah,
or-
yeah. So and you can, like, there's a lot of software programs that'll do it for you too. But what they don't do is give you the site-specific production data. And so we want to know how those panels will actually perform in Saskatoon in our conditions.
Okay,
So they don't account for snow cover.
yeah.
They don't account for emissions from QE power station affecting the, so we want to know the real number.
Okay.
So a solar company will give you a number,
Yeah,
but we've never seen anyone meet that
yeah.
production.
Are you trying different types of solar panels, like mono?
I think they'll all be the same
Okay,
on this project,
yeah,
but just the system types are different.
okay.
And part of our evaluation criteria for the project is environmental considerations. So how much energy went into manufacturing the panels? Are they recyclable? So there's actually a scorecard for different solar panel manufacturers, and that we're awarding 15% of the evaluation is awarded on environmental considerations. But we're not asking for mono or polycrystalline.
Where there's, different manufacturers, produce so many different.
No, not through this program. We might do some research on that.
So for the landfill gas, is it pretty constant output in terms of gas, or does it kind of fluctuate with the seasons a bit, temperature drops and stuff?
Yeah, good question. It does. The biggest impact is barometric pressure. And so when the pressure is higher, we actually get better production from the well because it's pushing down on the landfill. And so we're drawing a higher vacuum. So we, in the, when it's high barometric pressure, we're probably 58% methane. And when it's really low, it could be down to 52, 53. And we have to adjust our air-fuel ratio on the engines to match that.
So is that done automatically, or you adjust that?
It's manually, so it's, we also, at lower methane percentages, we also reduce the output because we had trouble staying online actually with the lower methane percent. But you can do dynamic air-fuel ratio control, but we'll have to change our governor system to do that. Right now, they're just manual. So in the future, we might, if that becomes a problem, we might automate it to correct that.
What's the lifespan of those wells? How long will they be producing gas for?
So the maximum production rate from the landfill occurs 1 month after closure, 1 year after closure. And it falls off probably 1 to 2% a year for 2 to 3 decades. And it really depends on the moisture content of the landfill. So if you have a much more humid waste mass, like they do in Ontario, for example, or BC, it'll produce gas faster, but for a shorter period of time. So there's only so much gas production potential in the waste. So you might get 15, 20 years in BC or Ontario. We're expecting probably 20 to 30 years here. But we're going to, so that's the older part of the landfill here, but now we're filling here and here. And so we'll expand the well field as the landfill grows. And so we're expecting probably 80 years out of this collection facility. The wells will probably be abandoned in the old part in 30 years. But we'll use the same collection facility and power generation ongoing for 50, 60, 80 years.
The engines have to be pretty much rebuilt entirely every 10 years or so. We replace the heads every year, every 8,000 hours. So it's a lot of money goes into it.